All right. We'll go and get started. People can come in kind of midway. That's fine. Before we actually start, I want to give you kind of a brief overview of what this is actually meant to be, at least as of right now. And it can change over time. It's kind of meant to help you guys. All right. So what this is a regenerated version of the practice test. So you guys got a version, you did it in class, and we were actually this time we were able to go through the class period after you had that chance. All right. So the practice quiz that I gave you, you already have all the answers to. We've gone over most of it, and you guys have been working on it for a bit. All right. This is a regenerated version of that. You can find it in on campus under that limits topic. Uh, so this is just another opportunity to practice some of these questions. All right, and that's what this usually is. Occasionally, I'll go over kind of broader topics. Um, I mean, if a ton of people have a whole lot of problems with a particular homework, uh, usually I can get on here and it'll help. Um, but yeah, so that's the plan for this. And as go through each of these things, if you have questions, please just let me know. Just type it in the chat. Um, this is about a 10-second delay. So if it's not answered like immediately, just be patient. I'll look over as much as I can. Just bear with me. All right. Um, so with that, we'll just go ahead and get started. All right. Um, I want to quickly go over the topics covered. It's nothing new. I just want to kind of list them so you have them in your head as we do these things. Um, Obviously we reviewed for a couple weeks, so function composition, solving quadratics, all that stuff. The big one that we've reviewed though is factoring. All right, and that's kind of a constant in all of this. All right, so it's very important to know how to factor. Besides that, we went over definition of what a limit actually is. Right, so a limit is what happens as you go from the left and from the right of a particular function, and it's what happens in the middle, or later on, it's what happens as you approach an unbounded area, so like infinity. So don't worry about that right now. We'll get there. All right. So as of right now, all it is what's happening as you approach a certain point. Then we worked at evaluating limits. All right, and this is where we spent most of our time. So we use direct substitution. That's where you just plug in a particular limit. You just plug it in for your input and get an answer. Okay, super simple. It's just like what you guys have been doing for the last couple of years. It's plugging in an input, getting an output. All right. Then we used dividing out and rationalizing. All right. So these two only happen when you have a potential to have a numerator of 0. Sorry, a denominator of 0. All right. And what that's meant to do is it's meant to cancel out that 0 in some way, shape, or form. So then you don't have that 0 and you can evaluate the limit again. All right. So that's why kind of I go through, the first step is to plug in, see if the denominator is 0. If it's not, great. If it is, here's a couple of things to do. All right. So that's when we use those things. The other thing we did was using trig identities and trig identity limits. All right, that's the sine of x over x is equal to 1, and 1 minus cosine of x over x is equal to 1, or at least the limits of those is equal to 1, right? So in these cases, you would imagine that we get a denominator of 0, so we have to factor or rationalize. But when we're using trig, it's a little bit different. All right, we have a couple identities here that just tell us that is equal to 1. All right, and with that, we actually also went over the unit circle. All right, so the things I'm expecting you to know here are the 0 angle, right? So I know this is kind of small and hard to see. The 0 angle, as we're all the way to the right, that point is 1, 0. And then the pi over 2 point, which is 0, 1. Again, I know that's kind of hard to see right now, but that'll do for now, I guess. And then the cosine of any angle is the x coordinate on the circle. and the sine of any angle is the y coordinate. All right. So that's what we spent our time doing. All right. And all of this practice quiz is meant to kind of capture that and see if you guys know how to do it. All right. So with that, we'll go ahead and get started with some of this stuff. All right. I will say I haven't actually done this yet. So hopefully this will go smoothly. All right. It should. But if you notice something that I do wrong, call me out. I'm not perfect every time I do this. All right. So the first two is really just meant to get you to think about what a limit is. All right. So we have the limit as x approaches -3. I'm hoping you can see that. If it's too small, I can make it a little bit bigger. And the first thing you got to ask yourself is there a potential 0 in the denominator? Now, there isn't for either of these two because the denominator is 1, right? So that's just a constant. The other thing you have to ask is, and we haven't really covered this, and you won't see it on this quiz, but the other thing you have to ask is what values of x would make the inside of this negative, right? Because we can't have that. Don't worry about that right now. We just got to plug in our limit and see what happens. So if we do that, we get negative square root of -2 times -3 plus 4, which simplifies to negative square root of +6 plus 4, which is just +10. And then that's our answer. Simple, right? Our limit exists. We know that because there's nothing that would tell us otherwise. And then that is our limit. Right, so just this is the answer. All right. Number 2, again, kind of do the same thing. There's nothing in this function that doesn't exist, so we just plug it in. So the limit as x approaches 0 of 2x plus 1 is just 2 times 0 plus 1, which is just 1. And that's our answer. Okay, you could also graph both of these things and just see what happens at those points. That's kind of overkill. You don't need to do that. You can if you want, but it is an option. But that's those two problems. All right, those should be the easiest problems that you guys do on the quiz. And I don't want you to think that just because they're the first two problems means that they're just a direct substitution problem. I want you to get used to seeing these types of problems and thinking, oh, there's nothing potentially 0 in the denominator, or there's nothing potentially imaginary, right? So that's what those will look like. All right. Number 3, I kind of want to move through these two. So normally I'll pause after a set of problems, but because those are decently easy, we'll move on. All right. Number 3 through I think 8 tell us to evaluate each limit by dividing out or rationalizing. So in this case, there is a potentially 0 value in the denominator. And really, that's all we're worried about right now. Okay. So the first thing you should always do is just plug in your limit. So x approaches 1. If we do that, though, 1 minus 1 is 0. And we have a 0 in the denominator, right? And we can't have that, so we have to do something different. Because there's an irrational, right? Because there's something irrational here, we can rationalize. All right, and the way we rationalize is we multiply this fraction by the conjugate of the top, or the conjugate of the thing with the irrational part, right? So in this case, that's the top. So we multiply by x plus 3, square root of x plus 3, plus 2, over square root of x plus 3, plus 2. Right, and the reason we can do that is because we're really just multiplying by 1. We're not doing anything fancy. We're not changing the function. We're just multiplying by some clever form of 1, which is totally legal. All right, when we do that, we have to multiply the numerators together and the denominators together. Now, you can factor, or not factor, you can FOIL if you want. You can do first times first, first times last, second times first, whatever the acronym is. You can do that if it makes you feel comfortable, but it really ends up just being this first term squared, which is x plus 3, minus the second term squared, which is 4. And then in the denominator, we'll make that a little bit neater. In the denominator, we get x minus 1 times the square root of x plus 3 plus 2. Now when we simplify that, we get x minus 1 in the numerator. And square root of x plus 3 plus 2 in the denominator, as well as x minus 1. All right. And then if you see that, you should notice that x minus 1 should cancel in both the numerator and denominator. And we're left with just the limit as x approaches 1 of 1 over square root of x plus 3 plus 2. If we plug in 1 there, if we plug in our limit, we get 1 over square root of 4, which is just 2, and then plus 2, so we get 1/4. All right, we'll go ahead and start the second one. Again, if you have questions on that, just feel free to ask. I'll just stop and go back and answer them. I'll try and move on as well. All right. The second one, number 4, at least. This is the limit as x approaches negative 2 of x squared minus 2x minus 8 all over x plus 2. Again, the first thing that we should do is we should check our limit. It's not a highlighter. This is a highlighter. Check our limit as x approaches negative 2. When we plug in negative 2, though, there's a 0 in the denominator. Okay, so that means we have to do one of two things. We either rationalize or we factor. Okay, in this case, there's nothing irrational about this function. But there's a quadratic, and maybe we can factor it. All right, so if we try and factor the top, we would need factors of negative 8 that add up to negative 2. Which is just negative 4 and positive 2. So we get x minus 4 and x plus 2. Right, so this is really just the numerator. It's just another way to write the numerator. And then we have our denominator. Again, you should be able to tell that x plus 2 cancels out with x plus 2. We're just left with x minus 4. Now when we plug in our limit, we get negative 2 minus 4, which is equal to negative 6. All right, and before we move on to the next one, I'll let you kind of look at that for a second. But I can't stress enough how important being able to factor is. It shows up all the time in future classes, in AP Calc, in future Calc classes and future stats classes. No matter what math class you take next year, which I'm guessing you're going to have to take some, and even on the ACT, right? Factoring is tremendously important. So if you're able to do it well, you're in a really good place. Rationalizing also comes up a whole bunch. All right. So those are kind of the skills that we're practicing, even though we're just introducing limits. Okay. So keep that in mind. These things pop up a whole lot later on, and they're crucial to your understanding for stuff later. All right. So I'm assuming there are no questions because no one's been asking about those number 3 and 4. So we're going to go ahead and move on to number 5. Again, number 5, we kind of do the same thing. I'll go through this a little bit quicker. Again, check your limit. What's your retake policy again? That's in the syllabus. It is you can retake anything or any test in this case, and you can retake this quiz. But it is, you tell me a time. In this case, we kind of got to take it this week or early next week. So my guess is that you would retake it Monday. But the highest score you can get is 11% lower than the last one. So in this case, if you got 100% on the retake, you'd only be able to get an 89. All right, and then it scales 89% of whatever you get. Yeah, it's a scale factor. So like I take 0.89, multiply it by your actual percentage, and then that's your grade. All right. So question for kind of a different time though. All right. So we check our limit. We get 0 in the denominator. So we need to multiply. Well, we need to do something. All right. And again, in this case, there's something irrational. So we can multiply by the conjugate of that thing. So in this case, the conjugate of that irrational thing is square root of x plus 2 over itself. When we do that, again, you can foil the numerator and denominator. It makes things a whole lot harder. This numerator is just the difference of squares. So we get x plus 2 minus 4, right? This x plus 2 is this thing squared. I'll erase these other highlights. And then this 4 is this 2 squared. And then there's a subtraction sign in the middle. Again, if you foil that, that's what you end up getting. It's just a quick kind of helpful tip. All right. And then in the bottom, we still have x minus 2 times square root of x plus 2 plus 2. All right. And then you should notice, right, if we simplify this numerator, that becomes x minus 2. So that entire thing cancels with the x minus 2 in the denominator. So really we have the limit as x approaches 1 of 1 over square root of x plus 2 plus 2. Which if we plug that in, sorry, this should be a 2. If we plug that in, we get 1 over square root of 2 plus 2, which is 4. Square root of 4 is 2. So we just get 1/4 again. Just kind of boring, but that's fine. That's what we get. All right. Number 6, again, kind of the same deal. We check our limit. We plug it in. There's a 0 on the bottom. We multiply by the conjugate of the top. Make some room. Our conjugate in this case is square root of x plus 14 plus 4 over itself. When we do that foil, when we do that math up top, we get x plus 14 minus 16. Again, this x plus 14 comes from this entire thing squared. This 16 comes from this 4 squared. And then all the middle terms cancel, right? That's kind of the whole point of it. And then the bottom, we have x minus 2, square root of x plus 14, plus 4. Again, if you simplify the top, that becomes x minus 2. So that cancels with this x minus 2. We plug in our limit. When we do that, We get 1 over square root of 16, which is just 1 over 4, and then plus 4, which is 8. All right, so I want to pause there real quick. Again, kind of let you digest that, and I'll give you time for a couple questions. So I'm going to mute myself, give you 10, 15 seconds to look at it, and then I want you to ask any questions you have. Otherwise, we'll move on. All right. I'm hoping people understand that. Again, if you have any questions, just let me know. You can also email me too. I'll probably take longer to answer, but all right. For factoring, do you just take the last number with an x? Like how did you know to use 8 to factor? In what number? What number are you talking about? Number 4? That's what I'm assuming you're talking about. How did I know to use 8 to factor? So in the top, again, if I think I'm understanding your question. All right, in order to factor, we need factors of -8 that add to -2. Right, so those factors, if we have -8, we need factors that add up to -2. So if we just go down the list, we can do -8, +1. But if we add those together, we get -7. We could do -4, +2. If we add that together, we get +2. If we reverse that, -2, +4. Wait, no. This is -2. Yeah, and then that's our answer. Okay, so it takes a little bit of practice. You might not get it on the first try. That's why, like, if I'm doing this, if I'm new doing this, I would recommend you write something out like this, just to have it out in front of you, so you're not constantly thinking in your head. Like, the more you get it on paper, probably the better. And if you need room to do that, I got scratch paper. That's all right. I hope that answers your question. But that's how factoring works. All right, good. And if you have questions about it, again, tomorrow morning or even tonight, right, we can go back to that. I can make more factoring problems. That's no big deal. All right. So 7 and 8. All right. There are kind of two ways to do these problems. You could graph this and answer it that way, which sometimes is actually easier. But I would like you to understand why these are what they are. And before we get to what they actually are, I want you to understand that just because they're number 7 and 8 doesn't mean they're going to be these types of answers. Okay? That's not necessarily the case. But I want you to understand why they are the case. All right? So, again, like any limit, we plug in our limit and see what happens. So if we do that, we get -2 over -2 plus 2. We get -2 over 0. Okay. So this is just something that cannot happen. All right. So in this case, the limit does not exist. Now, normally, what I tell you is that once you get a 0 in the denominator, you have to factor something out, or you have to rationalize. But in this case, if we try either of those, nothing's going to work, right? So there's nothing to factor between x plus 2 and 2. Some people who will remain nameless will think you can cancel out this 2 and this 2. That is not the case. Okay, that does not work at all. It goes against all order of operations. All right, so you cannot do that. So don't. I don't like that. And neither does math. All right. If you try to rationalize it, you're still going to get, I think it's 0 in the denominator. All right, so we get negative 2. When we plug in negative 2, again, we get 0 in the denominator. All right. So no matter what you do that you know of right now, it gives you 0 in the denominator, which, again, for right now means the limit does not exist according to those like 3 conditions, right? So we had non-existent limits. I think that should be an E. Yeah. Unbounded behavior. Differing behavior. And there's one more, which I will think about here in a second. All right. But this would follow the unbounded behavior. I'm not expecting you to write that, but that's what's happening. Okay, so if we do the same thing for number 8, again, we plug it in, we get negative 2 over 3 squared minus 9. 3 squared is 9, so we get negative 2 over 0. It doesn't exist. There's nothing we can do about it. So this does not exist. And then so is this one. You can write D and E, you can write does not exist, you can write the null set. Whatever you want to do, just make sure I know that you know that it does not exist. Yeah, I'm still trying to think of that third condition. All right. Number 9 and 10. These are actually easier than what they probably look like. You will get some kind of fancy looking function. All right, this is the integer function or the natural number function. It's the rounding function. That's what it's called. At a certain limit. All right, so we check that limit. Can we see an example of a limit that does not exist? Yeah, it's these two. Those are limits that do not exist. So are these, actually. And here's why. Limit does exist. Yes. These two. And actually, these top two, these 4 right here. Yeah, so most of the ones we've worked with will exist. Yeah, the top half of the test all exists. Some we have to finagle, but they do exist. All right, so number 9 and 10. I hope that answers your question. Again, we can go back to it. But yeah, most of this test will exist. All right, number 9, we go to x is equal to negative 3. And we look at what happens kind of along that line. All right, so along that line, as we approach this vertical line, we need to see what happens on both sides of the graph, right? So if we start on the right, we go to some y value. That y value is 5, and I'm going to write it up here. If we start on the left side, we go to some other y value that's negative 6. Because these two things are not the same, the limit does not exist. Right? That's a differing behavior from both sides. Kind of the same thing on this one. Again, we go to our limit. I like to draw a line. And we see what happens as we go from the left and from the right. All right, so as we go from the left, if we start on the left, go to our limit, we get some y value. That y value in this case is -2. And then we start from the right, go toward our limit, x is equal to 0, and we get some y value. In this case, the limit is -6. These two things are not equal, so the limit does not exist. I want to pause there before we get to the trig stuff. And I'll let you kind of ask questions if you have them. What about a graph that does exist? Yeah. So that was actually, there's a couple on your other practice tests, but I can draw one. All right. You can get some function. I think the example that I liked was something that looked like this. No. Right, so it was a line up until some point and then a parabola after another. And we were asked to find the limit as x approaches, let's say this is like 2 or something. So as x approaches 2 from both sides, again, we start at the left, go toward x equals 2 along the graph. We get some y value. I think this was -2. We start from the right, we go toward our limit along our graph, and it hits the same point, right? So because these two things are the same, that limit does exist. And I realized I was talking down and away from the mic. I hope you heard that. But that's, yeah, if from the left and the right of the limit, if those two things approach the same point, then the limit exists. Right. I do want to move on to trig. And actually, these were the same. I didn't mean for these to be the same. I think I just have to type out new ones. But they're good practice, right? So being able to do these kind of on the fly is helpful. All right, so let's go ahead and do these. And I'm going to write out some identities. So these are the tools that we need to know. All right. This one's kind of a bonus, but you should know it. Yeah. And then besides that, just kind of working with fractions, being able to manipulate them. Right. So let's say 1 over x. It's really just equal to x. Okay, so different things like that, like working with reciprocals, knowing what dividing actually means, that'll help. And if you can do that, you should be fine, right? So 11, let's rewrite, actually, oh, okay. So these rules are important, but then so are the properties, right? So the limit of, let's say, like 4x, we can get rid of that constant, so this is just 4 times the limit of x, right? So that applies to this as well, right? So this 3 is on the outside of any function, so we can get rid of it. All right, so we can rewrite this as 3 times the limit as x approaches 0 of tan of 4x over x. Okay, we can't do that with the inside. We can't do that with this 4x because it's inside a function, right? So if we factored that out, if we got rid of that 4, we'd be getting rid of more than just 4, all right? And we don't know what that actually is, so we cannot do that, all right? Okay, so then what I would do is rewrite tangent, because none of our tools tell us what the limit of a tangent is, right? We do know what tangent can be rewritten as, so we can just write it like that. Okay, so this is 3 times the limit as x approaches 0. And then tangent of 4x can be rewritten as sine of 4x over cosine of 4x. And because we're dividing by x, we're really multiplying by 1 over x. So I'm going to write that. Yes, it would be 1/3. Okay, then we can move things around a little bit. To get this. And then our properties say that we can rewrite this as 2 different limits. You don't need to do this. I like to do it because it helps explain things. Right, so all right, and then we can start to kind of clear things up a little bit. All right, so I want to focus on this limit right here, because this limit we can evaluate pretty easily. All right, so if we plug in x equals 0, we get 1 over cosine of 0. 1 over cosine of 0 just becomes 1 over 1, which again is just 1. Right, so this entire thing just goes to 1. That's canceled out. We don't have to worry about it. Okay. Then we have 1/3 the limit as x approaches 0 of sine of 4x over x. Oops, skipping ahead. And we need to evaluate this. All right. Now, our rule says that we need anything inside parentheses for the sign to be equal to the thing in the denominator. Right, so this 4x has to also be down here. So we can make that happen by multiplying by 1/4 inside. And what we multiply by inside, we have to multiply by outside. Then we have sine of 4x over 4x. All of this goes to 1, and we're just left with 4/3. Number 12, it's kind of the same thing. Um, Again, it's just rewriting things to what they're equal to. So the limit as x approaches 0, I'm going to rewrite tangent as sine over cosine. Oops. This cosine and this cosine cancel. So we're left with the limit as x approaches 0 of sine of x over x, which just cancels to 1. So I want to pause there, give time for some questions, and then we'll move on. All right, last two. Again, I apologize that you guys have already seen these, but same concept, worth the practice. All right, for 13 and 14, again, the general rule should be to plug in your limit, just no matter what, and then that'll tell you a lot about what you need to do. Okay, so in this top one, we get the limit, and actually, we have two constants. All right, so we can just write that on the outside. All right, so this becomes 4/2, the limit as x approaches pi over 2 of sine of x. Okay, so this just becomes 4/2 times sine of pi over 2. And if you recall from your unit circle, pi over 2 is right here. That point is 0, 1. We're looking for the sine, so that gives us the y value. So sine of pi over 2 in this case is just 1. So this entire thing equals 4/2, which is just 2. And then it's the same thing for number 14. Number 14 is actually easier because there's not the constants involved, but it's pretty much the same problem. All right, so limit. Actually, we don't even need to do this. You just plug in pi over 2. So sine of pi over 2. That's just equal to 1. Okay, that is the practice quiz. I'm going to kind of give you guys some time for questions, so I'll give time on this page and I'll gradually scroll up. But again, if you have any questions at all, now is a great time to ask. All right, I get that it's almost 9:20 right now, but if you have questions, let me know. That way I can at least help you study, as opposed to you just kind of going off and racking your head against one problem for, you know, an unnecessary amount of time. Okay, so I'm going to leave this open for the next 5 minutes or so. As you have questions, I'll answer them for however long it takes. If there's no questions after that, then I'll shut it down. All right, so take a look at it. Are we going to have to draw the unit circle on the quiz? No, you don't have to draw the unit circle. I'm just kind of showing you why it's 1. And it's honestly, there's a lot of work that I show that you don't need to. I only show it so you guys understand why. Like I would expect to see, whoops, oh, that's not good. I would expect to see this because that's kind of an important part. But like if you get down to sine of 4x over x, and you just call that 4, and then you get an answer of 4/3, that's totally fine if you skip there. And let's say we write out all of the work correctly, but end up getting the wrong answer. Wrong, do we receive partial credit? Yeah, I give partial credit all the time. I'll have a rubric. Usually it's based on the number of steps or the specific steps. Right, so let's take number 12, for example. Number 12 is probably a 3-point problem. The first point you would get is, my God, stop it. The first part of the problem would be rewriting tangent as sine over cosine and then canceling it. The second one would be, actually understanding that it's sine of x over x. And then the third would be understanding that that limit is 1. Right, so if you get to the second step, but then get the answer wrong for whatever reason, you still get that point. How do you know that tangent goes to sine over cosine, and do others translate to different ones? For now, and I know this is kind of a cop-out answer, anytime you see tangent, you probably need to write it as sine over cosine. There are identities later on that tell you otherwise, that only work with tangent, but you haven't seen them. So in all honesty, use that to your advantage and just always write tangent as sine over cosine. And keep in mind, it's a couple people asked me this before. Tangent of 4x, that goes to sine of 4x over cosine of 4x. It's the same in both of them. And do others translate to different ones? Again, yes, but you don't know it. So, again, use that to your advantage for now. Charlie, for 1 and 2, how do you expand the problem? Oh, that's right. All right, so I want to go up to number 1 and 2. You bring up a good point. All right, there are actually 2 parts to this problem. Using the properties of limits, expand the following, then evaluate. All right, so we really just did the second part. All right, so this is part 2. I'm going to make this a little bit smaller. Great. All right, expanding. Yeah, all right. Number 1 is maybe a little bit trickier because it's just looks different. All right. And I'll probably try and shy away from this type of question, but we can rewrite this as negative 2x plus 4 to the 1/2. All right, so in order to expand this, I would say this is negative limit as x approaches -3 of negative 2x plus 4 all to the 1/2 power. So again, I'll probably try and shy away from a square root, but let's say instead that I ask for the limit as x approaches, I don't know, 4 of 3x squared plus 2x plus 1. Right, expanding would really mean, and actually, I'll get rid of this 2x. And then let's say like over 4x. Yes, you have to expand on the test. That was part of the properties. I just forgot to go over that. So again, make sure you read the directions, which I did not do, even though I wrote them. right? So we could expand this as the limit as x approaches 4 of the numerator over the limit as x approaches 4 of the denominator, right? So that would get you full credit. I'm not looking for anything super serious there. I'm just looking to make sure that you guys understand these questions are often or can often be broken into smaller parts. And it's actually easier if you do that. I understand that this is just a direct substitution type problem, but as we get later and later, it's helpful to be able to break things up into smaller problems. And then for the second one, we can rewrite this as the limit as x approaches 0 of 2x. And really, we could write it as 2 times the limit of x plus the limit of as x approaches 0 of just 1, which is just 1. Right? So that would be like, that's everything. You could also do limit as x approaches 0 of 2x plus the limit as x approaches 0 of 1. That would also get full credit. Okay, again, I'm just looking for you to be able to expand in some way, shape, or form. Any other questions? Again, now is a great time to ask. So if you have questions over anything, don't hesitate. And as you think or as you look over some of the work, I'll kind of scroll through. I'll spend 10 to 15 seconds on each like set, and then I'll scroll forward. But as you have questions, just feel free to ask. Is the test going to look like that, or will it be like a multiple choice thing? No, it's going to look like that. Again, like I said, my test is just my practice test regenerated. Occasionally, I throw in like I change a problem or two, but for the most part, it's about the same. Regardless, though, like even if I like again, I'm not going to do this, but even if I change the format, all of these questions, all these types of questions would show up. Which hopefully, between the practice test, this regenerated practice test, along with all the review questions that I gave you, right, you'd be able to do each one. And the homework, right? Everything's a build-up. No problem. All right, again, I'll keep this open for a couple minutes. So like, if you're totally done, by all means, you're free to go. But if you do have questions or just want to look it over, I forgot to scroll. I'll scroll down. Um, you're you're welcome to ask too. No problem. But again, I'll tentatively say 5 minutes from now. If there's no questions, I'll shut it down. No problem. Can I explain where the 1/3 came from in problem number 11? Yes. Uh, the 1/3 came from. I'm gonna clean this up a little bit. Hold on. The 1/3 came from this constant, this 3. So because like it's not inside a function, right? So we can factor that out. So this is really like this entire thing is tan of 4x over x times 1/3. And because this is a constant, our properties, the properties of the limits that we went over kind of the first day we actually did limits, those properties say that we can factor this out and put it out front. I hope that answers your question. So if you have a constant as a coefficient, you can put it out front. Yes. Yeah. That's it. It makes your life a whole lot easier. The more you can break these down into smaller pieces, the better. Right? So taking out that 1/3 honestly simplifies it a little bit and makes it a little bit easier to see what you actually need to do. So the more you can do that, the better. This this entire class is not entire class. Pretty much every let's say 70% of all you do in math, at least for most classes, is make things look like other things. So the more you can break it down into smaller things that you know, the better. And that moving that 1/3 out just makes it a little bit easier. Perfect. All right. I'll give this another 2 or 3 minutes. Obviously, people are still kind of filtering through this, and that's fine. So let's say 9:38. If there's no questions by then, I'll shut it down. All right. It is 9:38. There are no other questions, so I will shut this down. Um, Again, if you have more questions, you can always come in tomorrow morning, but this is also going to be available as soon as I hit end. So if you do have questions, go through this, see if you can answer it. If not, I'll be available. All right. So thank you for coming, and I will see you tomorrow.